Hi everyone, it's Mrs. Summer here to talk about lesson 208, Lewis dot structure for covalent compounds. In this lesson, students will be able to draw Lewis structures for compounds and molecules, identify the number of bonds likely formed by an atom based on its location on the periodic table, and identify the number of bonds likely formed by an atom based on its location on the periodic table. So if you remember, to draw the Lewis structure of an element, you use the group number on the periodic table, because that group number tells you how many valence electrons each group has. In covalent bonds, Lewis structures are represented by dots, and they represent single electrons, and a line that represents a paired shared of electrons, so 2 electrons. So in chlorine, or carbon tetrachloride, it has 4 groups of shared electrons, and then each chlorine has 3 sets of lone electron pairs. And if you remember, hydrogen is the exception to the octet rule. Hydrogen only has 1 valence electron. So in order for hydrogen to have a complete energy shell, it only needs 2 electrons. The same for helium. Helium only needs 2 electrons to be full. It's called the duet rule, and it's only for hydrogen and helium. Okay? The steps to drawing Lewis dot structures for covalent compounds is find the total number of valence electrons. So this is for covalent. So you should write these down in your notes so you know you have them written somewhere. Steps for covalent compounds. Okay, we find the total number of electrons, place the element in the drawing, then we're going to draw 2 electrons between atoms to form a chemical bond. Use a line to show if they are sharing the pair of electrons. And then use the rest of the dots to finish your Lewis structure. So here we're going to fill in a table. So find the total number of valence electrons. So the first element is hydrogen. And its symbol is H. The number of valence electrons that hydrogen has is 1. Number of atoms, there are 2 hydrogen atoms, because see this 2, it represents the number of hydrogen atoms. So the total electrons is 1 times 2, which is 2. And then the next one is oxygen, and its symbol is O. The number of valence electrons that oxygen has is 6, and there's only 1 atom of oxygen here, and so the total number of electrons is 6, and then the total electrons that we have to figure out where they go is 8, because 2 plus 6 is 8. Now we have to place the elements in the drawing. So we're going to place the element with the least number of particles in the center of your drawing, and then place the elements that you have more particles of symmetrically around your center element. So we're going to first place oxygen in the center, and then we're going to place hydrogen there. So hydrogen has 1 valence electron to share with oxygen. Okay, then oxygen we used 1, 2 from oxygen, and we have 6 more to place. So our Lewis structure kind of looks like that for oxygen, or for H2O, which is water or dihydrogen monoxide. So now we're going to draw it with our lines to represent. So we have oxygen, and then hydrogen, and our double lines, because those are the ones that are bonded to each other. And then we're going to draw the lone electrons Because oxygen, you'll find out as you're doing these, likes to have 2 pair of lone electrons. If we count up the total number of electrons, because a line is 2, so 2, 4, 2, 4, 5, 6, 7, 8. We have used the total of 8 electrons in our that we needed to find a place for in our diagram. Okay. With covalent compounds, we have single, double, and triple bonds. So hydrogen must have 2 electrons. All other elements must have 8 electrons. If it doesn't work out that this is how many electrons and you have too many electrons, you must transfer pairs of dots to make double or triple bonds. So with oxygen, a single bond is 1 pair of electrons that are shared. The double bonds, 2 pairs of electrons shared. Triple bond, 3 pairs of electrons that are shared. So a single bond is just 1 line. A double bond looks like that, and a triple bond will be represented with 3 lines in between. Okay, write those down in your notes so that you don't forget. So for here, oxygen bonded to oxygen, so diatomic oxygen, we have a total of 12 electrons. Because there's 6 valence electrons on each oxygen, there are 2 oxygen atoms, so 2 times 6 is 12. Well, let's count. 2, 4, 6, 8, 10, 12. Okay, so that is how we have 12 electrons, but look, this oxygen has 2, 4, 6. It only has 6 electrons around it when it needs 8. This one has 2, 4, 6, 8 electrons. So now we have to figure out how to get them a double bond. So we can remove those 2 and double bond it here. Draw a better line here. So now it has 2, this oxygen has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. So they are both happy and content with their 8 electrons around them. Here's another example we have diatomic nitrogen. So right now, the way this is drawn as each nitrogen has 2, 4, 6 around them. Well, they want 8. So, and we have 10 electrons that we have to figure out. So this has 2, 4, 6, 8, 10. We have the total number of electrons correctly, but we don't have the octets filled correctly. So we'll start by placing another double bond. That gets us an octet because we have 2, 4, 6, 8, 2, 4, 6, 8. But then how many total electrons do we have? 2, 4, 6, 8, 10, 12. Well, that's not 12, does not equal 10. So now we're going to remove those again. We're going to give it a triple bond. So 2, 4, 6, 8, 10. So yes, now with the nitrogen Lewis structure looking like this, it's both happy and its octet is full. So here's the answers to the previous examples we just did.